Okay, now let's talk about rates of change. This is a really, really cool part of calculus, and it has so many applications. The primary application we're going to look at for this unit is to physics. Now, a rate of change simply is something that changes with respect to time. So suppose I have a particle that's traveling. Oh, I have an eraser on. That's traveling and it's making some path. All right. And in general, we start at t equals 0. So let's say this is our displacement versus time graph. The rate of change of the displacement with respect to time is called the velocity. Now, you will do quite a bit more with velocity in physics, but the velocity is just the change in the position divided by the change in time. And this is average, so I'm going to put a bar across. This is average velocity. We'll talk about instantaneous later. All right. Now, it turns out that your velocity with respect to time is the derivative of your position with respect to time. And it also turns out that your acceleration with respect to time is equal to the derivative of your velocity. Now, this is a bit more than you're going to do in physics. You're going to probably only deal with constant accelerations. Um, but anyway, this is kind of cool. So velocity is the derivative of position, and velocity, yes, and acceleration is the derivative of velocity. We'll do a bit in class with relating what all of these graphs look like. You can tell on a position versus time graph when something has a larger or smaller rate of change by, of course, looking at the slope between the 2 points. So if I have this point and this point, I have one slope between my lines, where if I have this point and this point, and let me change colors here so you can see it, I have a much different rate of change. And so we're going to be looking at average velocities here. Okay. Now I want you to turn on the tape and do this problem in your notebook. When you're done, turn the tape back on because we're not done yet. Now this is a general formula. The position with respect to time is S naught, and S naught is your initial position. It quite literally means position at times t equals 0. V naught is your initial velocity or speed. There is a difference in speed and velocity, but we're not going to get too much into that right now. So this is your initial, I'll just go and call it speed. Now, your initial position is positive if it's to the right or up, and it's negative if it's left or down. And that's true for your initial speed as well. Now we have this second part here. G, now we're talking about free fall problems right now. Um, G is the acceleration due to gravity. So if I take a ball and I throw it, it's going to follow this parabolic shape. You've all seen footballs thrown. You know how they go up and they come down. All right. Um, this is what, your position time graph looks like. All right. And you have acceleration right here that we're going to call g. Now g has two values, and you're going to see both of them in problems. G is 9.8 meters per second squared. And you're going to see this in physics all the time. So 0.5 g is 4.9. So you might see that in one of our formulas. G is also 32.2 feet per second squared. So 0.5 g is 16. Um, in general, I don't put units on here because when we're using them in mathematical formulas, we don't put the units, but you might need this for a problem or to help you figure out a problem. So you have the initial speed, initial position, initial velocity times time, plus 1/2 gravity times time squared. Now I told you that velocity is the derivative of position. So what is the derivative with respect to time of s of t? Let's see, it's a derivative with respect to time of s naught plus the derivative with respect to time of v naught t plus a derivative with respect to time of 0.5 gt squared. So let's see, that's 0. This is v naught plus 0.5 times 2 gt. So this is v naught plus gt. Now one hint, gravity in these equations is actually negative. You'll see this equation in your physics class, and we've now derived it for you. Actually, this is technically an A. That's what you'll see in your physics class. Now let's look at what acceleration is. I already told you acceleration is a derivative with respect to time of velocity. So this is a derivative with respect to time of v naught plus a derivative with respect to time of gt. That's 0, it's a constant, and the derivative of gt is just g. So in all of these problems, your acceleration is gravity. Now you're going to need to pay attention to your pluses and minuses. In physics, on the B test, you can use calculus. You do not have to. As a matter of fact, all of the problems can be done without calculus. But if you forget a formula, and you know the first formula, you can find your way all the way to acceleration. Now, let's find the velocity of this function. Velocity of t is the derivative with respect to time of s. So this is a derivative with respect to time of 15 plus a derivative with respect to time of 12t plus a derivative with respect to time of negative 16t squared. So this is, that's 0, 12 minus 16 times 2t. So this is 12 minus 32t. Okay, now your turn. See if you can do these. When you're done, turn off the tape and finish your homework.